Hey all, this is Derek, and this will just be a quick little review of basic operations with fractions. So first thing that we can encounter when we're working with fractions is that they need to be simplified. So that's these first couple of examples. To simplify a fraction, if it's something, super easy, 3/6, and you just are looking at it and you're like, yeah, that's 1/2, I know that, because 3 goes into 3 once, 3 goes into 6 twice. That's great. Sometimes when the numbers are a little bit harder to see, like with this 45 over 36, that one might be a little bit harder to spot than nines. A way of thinking about it, even if you don't write it out, is by factoring. So here we got 9 times 5 would be my numerator, and down here 9 times 4 would be my denominator. And then you can see 9 over 9, that makes 1, so that would cancel. 9 over 9 is 1, leaving us with 5/4. And so you certainly don't have to show all those steps. But sometimes if the numbers are a little bit harder, that can just sort of help to organize yourself. So looking at 15/42, so something interesting with that, if reducing fractions can be called interesting, 15's not a very interesting number. It's 3 times 5. And so the only numbers that are going to work with this 42 are either going to be a 3 or a 5. So then I know it's not 5. 3 goes into 42 14 times. And so then I can see my canceling. So sometimes the factoring is good just to kind of spot what to do. So there's a little review of how to reduce. Next up, we're going to use that same skill, but with multiplying and dividing fractions. And so I have the steps written out in the notes, but I think I'll just talk through them in the example. Okay, so when we're multiplying fractions, we could potentially just multiply straight across, and then that would be, I think, 105 over 10, and then I would have to reduce. The easier way, so 7 over 5, and then is to kind of think of it as that factoring and canceling that I just did in those last two examples. So 15 again, that's a 3 times a 5 over 2, and then anything that's both in the numerator and the denominator, like this 5 over 5 right here, 5 over 5 is 1, and then what's left is going to be our reduced form. So 21 over 2. I could have gotten there by multiplying straight across, 105 over 10, but then I'd have to go 5 goes into 105, okay, 21 times, 5 goes into 10, 2 times. So it's actually a lot easier if you reduce before you multiply or divide, as in the next example, than if you do it afterwards. For division, it's basically we're just going to rewrite it as a multiplication. So when we're dividing fractions, you might remember that you flip where you take the reciprocal of the second fraction. Let's talk about why that is for just a second. Let's say I'm saying 10 divided by 2. We totally know that's 5, right? If we have $10 and we divide it amongst two of us, we each get $5. So 2 is 2 over 1. If I rewrite this as a multiply, I would rewrite it as 10 times 1 over 2. So there's the reciprocal. So then what's half of 10? It's still 5. So dividing by 2 is the exact same thing as multiplying by half. That's why this trick with the reciprocal works. So that's what we're really doing. So let me rewrite this one down here a little bit bigger and as a multiply. So we had 22 over 5 and then divided by 33 over 10. So I'm going to rewrite that as multiplied by 10 over 33. And then here you can just start canceling, and I'll show that in a second. I'm going to write out like this. Let me do it two ways just to kind of show. So this would be 2 times 11, and this is 5. The 10 is 2 times 5, and 33 would be 3 times 11. So if I cancel everything out, that's the same. 11 over 11 makes 1. 5 over 5 makes 1. And what would be left is 2 times 2 would be 4. And then there's nothing here, so that's like a 1. 1 times 3 would be 3. So that's showing it factored. You don't have to do all that. If you're comfortable with this, you can just come back here. So let me kind of show you the shortcut now. So looking at the 5 and the 10, I can just go 5 goes into 5 once, 5 goes into 10 twice. If I can spot that 11, 11 goes into 22 2 times, 11 goes into 33 3 times. And see, that's actually a lot cleaner. 2 times 2, there's our 4. 1 times 3, there's our 5. So if you're comfortable with this, I like that better. But if you have a lot of trouble trying to see what's going to cancel, there's kind of a longer route that's going to help you spot those values. These next couple are just kind of remind you what to do when you have a fraction with the whole number. So 3/8 times 24, or 3/8 of 24 is another way of saying that. So I'm going to write that 24 as 24 over 1. So it's really the exact same as what we've been doing, right? Here, I'd probably just go 8, and then go, okay, 8 goes into 24 3 times. And then 3 times 3 is going to make 9. This is like over 1. Sometimes people will type that in the computer because it was over 1, and then the computer marks them wrong, and that's because that's not simplified. If you're leaving a $9 tip, you wouldn't write it 9 divided by 1. You would just write 9. So make sure to simplify your fraction and just make it a whole number. And then one more with this divide. So this was 50 divided by 15 over 2. So I'm going to write it as 50 times 2 over 15. And so I could make this 100 over 15 and reduce, or I could kind of go, oh, I see some 5s going on, right? So 5 goes into 15 3 times, and 5 goes into 50 10 times. And this 50 again is like a 50 over 1. So now we got 10 times 2 gives us 20 up top, and 1 times 3 gets us 3 in the denominator. Okay, and then lastly, adding and subtracting with fractions. Again, here's kind of the box with all the steps. I'll talk through them as I do problems. So the key thing with fractions and addition and subtraction is they have to have the same denominator. So we cannot add things like, for instance, 1/4 plus 1/2 is the one I always use. So what that doesn't make is 1 plus 1 is 2 and 4 plus 2 is 6. That is like super make-believe math. This is where I always bust out a pizza and I go, okay, so if I ate half of this pizza, and if whoever you are out there ate a quarter of the pizza, that does not mean we have eaten 2/6 of the pizza, right? So something has gone wrong there. So what ends up having to happen is we got to get a common denominator. So in this case, it's going to be 2 over 2, so that we're in terms of fourths, because then we're comparing the same size pieces. You're 1/4, I ate a half, but I can also think of that as, right, that half is 2/4. So you ate 1/4, I ate 2/4. Together we ate 1, 2, 3 out of 4 pieces. So for adding and subtracting, gotta have the common denominator. So for this first example, sweet, we have a common denominator. We don't have to do too much. We can just add our numerators in this case. So 4 and 2 is going to be 6 over 15. But then there's that last step, reduce if needed. So anytime we are combining fractions, we got to pause at the end and go, oh wait, is there anything that goes into both? And yep. So this 6 is a 3 times a 2. That 15 is a 3 times a 5. So I can reduce out those 3's. My reduced form is going to be 2/5. Next example, so a fraction with a whole number. So plus 4. So remember that 4 is just like a 4 over 1. And then here's where I need to get find the common denominator and then make them the same. So that's kind of what I did up here. So this has a denominator of 3, so that means I want to make this 4 in terms of 3, or thirds. So 7/3, and then 4 times 3 would make 12/3. And see how 12/3, it's the exact same thing as 4. I'm just saying 4 in terms of thirds, and there would be 12/3 or 4. And now I can add my numerators because I'm adding the same size pieces. So 7 and 12 for 19, and over 3. A note on this improper fraction, for the rest of math, this is good. Leave the answer like this. Occasionally in some sort of like application problem, they would have you change that to a mixed numeral. But the thing where some teachers like you have to make that 6 1/3 or the universal end, not so much. We actually like the improper fractions. So put them in the computer just like that. Okay, so for this one, let me write it a little bit bigger down here. So we need a common denominator. You can always just multiply the two things together. That would always get your common denominator, but maybe not the lowest common denominator. So with this, 3 already goes into that 18. So the 18 is cool. This 3, to make it look like an 18, to bring it up to 18, I would just need to multiply by 6. And I don't think I've said it yet, but I'm doing 6 over 6 right because that equals 1. So I'm not changing the value of this, I'm just changing the look. So that gets us 6 over 18 and 7 over 18, or 13/18. Nothing reduces, so that's our final answer. And last one is a subtract. This time the numerators have absolutely nothing in common. This 18 had a 3 times a 6 in there, right? So this 3 needs a 6. 3s and 7s are both prime, nothing common. So all I can do is multiply each one by the other. And so that's going to get me 7/21 minus 3/21, or 4/21.